Sweet. All right. Hi, everyone. How's it going? Excited for the day? Sweet. Well, my name is Sai. I'm an HPC engineer at G Research. And, yeah, let me go to this slide. So, I went to University of South Carolina for computer engineering and graduated in the fall of 2023. And immediately after, I joined G Research as an HPC engineer. So, I've been there about a year, a little over a year and a half now. But before I explain to you guys what G Research does, let me explain to you what HPC is, and then I'll get into how we use it at G Research in our use case. So HPC, or high performance computing, is the use of some of the latest and greatest networking, compute, and storage technologies to orientate your platform for peak performance. That's literally what it is. And G Research has an HPC infrastructure of over 13,000 GPUs, a little under 500,000 cores of CPUs, over 240 petabytes of storage, and all of that comes together to run roughly 50 million jobs per day. That's almost 600 jobs completing their life cycle every second. G Research is a financial research firm that uses its HPC infrastructure to be able to simulate large financial models, do data analysis, and we use lots and lots of compute. And we work closely with NVIDIA, HPE, to be able to be on the edge of providing this compute. So when I joined GR, initially at that time, I was a bit apprehensive of trying to understand what I'm actually doing, right? And when I started brainstorming on how to give this talk, I initially realized okay, I need something that I can hook on back to in my other previous parts of life. And I realized one of the books I read immediately after graduating high school was The 7 Habits of Highly Effective People. And I want to use that as a backbone for my talk today because this is my first talk ever at a conference. And so I want to present to you guys the 7 Habits of Highly Effective HPC Engineers. So, as I said, when I joined GR, I had no experience in cloud or HPC infrastructure. I did research at University of South Carolina in AI, and I did quite a bit of low-level FPGA work and also a lot of robotics. But I had no HPC background, right? So I was quite apprehensive in working like a normal engineer without any concern. So I did not, at that time, understand on how to essentially work day to day without breaking things. So I was very apprehensive, and this led me to having a very defensive approach in my work, right? So it caused a lot of pitfalls. I was, learning things. I was learning things slower than others because I was afraid to break the cusp of learning, and over time, I broke that defensive barrier. I'm not as defensive anymore, but there are 4 things that fall under this habit of being proactive I want to share with you. So as an engineer, you should always anticipate for bottlenecks. HPC is essentially, you're on the leading edge of technology. And this is almost like a moving window. So You're constantly learning. You're constantly trying to identify bottlenecks in your company or in your, area of work to be able to, identify what you should bring on next. And that means, figuring out what tools your company already has to identify those bottlenecks. If you don't have those tools, figure out what others are using in this industry. This is not a new industry because we had, HPCs a year, 2, 3 years ago is a little different, but the tools to monitor are still the same, relatively the same. And also avoid, second. So also try to automate repetitive tasks. When you have 1 in a million, when you're hitting an error 1 in a million, right? That's 1 in a million, but that's 10 in 10 million. That's 50 in 50 million, right? You're not going to hire 50 different people to solve the same issue over time, right? So that means you need to figure out ways to automate. And this meant for me, I had to learn Ansible. My company uses Ansible and Jenkins on a day-to-day basis to roll out changes and test things. And also you need to stay ahead on technology. Because this is a moving window, this means, internet, look out. What things you might need to learn in the future, right? It's always good to be on that edge. Sorry. Ooh. I think I'm going a little quick there, but thank you for being patient with me. But yeah, so, and lastly, documenting. I did not know when things broke what to do, right? We had very big incidents. And one of the things that always kept me, on call without being on my phone, always looking, reloading, checking the incident reports, was the fact that we had proper run books. If your infrastructure is falling, your management is going to know immediately. But as an engineer, you need to figure out what you should do. Incidental management is a very poorly handled thing in lots of companies. That is something, through the help of Reddit, I found out that, hey, some companies are doing a very abysmal job at managing incidents. And so documenting, whenever you also find a bug that you fixed, there's probably someone else in your team that's going to go through that bug. Why send them through that whole learning curve? And you can just document or share a quick note somewhere, and they don't have to go through the same experience as you do. And that brings me to the second habit. So this is begin with the end in mind. All right, a story time. The domino effect of database syncing. So at G Research, we have 2 platforms to provision compute. We have OpenStack, an open source platform to manage and provision compute, storage, and network. And we also have another platform called Venus. Venus is an internal tool that was written by GR engineers, and it's essentially like a set of Ansible playbooks, and with a front end with a UI to kick off jobs, or you can use Jenkins and REST API calls to be able to make calls to the Jenkins to be able to automate without having to go through the UI. And we at GR didn't really have a good way of identifying what OS versions, like different instances like VMs or your servers or your hosts were on the 2 different platforms. So the management at that time gave me a task of essentially creating a job that is timed, and that job essentially syncs the database of OpenStack into our internal database, so they have a consolidation of all the different patching versions that the servers are on, such that they can identify which teams need to be proactive in upgrading their OS or patching their OS to their servers. And this is where I screwed up. So this was 3 months into me joining GR, all right? I knew how to program, I knew how to work with databases, but I did not know how to manage teams. There are 4 things I failed to do at that time that led me to butchering this project. So firstly, I failed to determine the scope of the project. So I would sync the database with the names and the server info, but then another team comes in and is like, oh, we need to have the UUID of the instance. And then another team comes in, they're like, oh, we need the UUID of the image. And this is what you call scope creep, right? The scope of the project got pushed farther and farther and farther back, and this led to the project being delayed by over 2 months, right? And also, you need to identify the stakeholders when having a project like this. If you're working in a team, ideally, you already have people within your team that can help you. Figure out who you should go to if you're new to a company or if you're new to this team, right? Figure out who you should go to work with projects like this, because your stakeholders are often going to be the ones that are going to determine the scope of your project, and also they're going to be the ones that you will report to. And thirdly, determine a proper channel of communication. This can be something as simple as a Slack channel or a weekly email thread or a bi-weekly sync up, but determine that channel of communication so everyone is in sync on a given period of time, rather than you directly messaging one person and then another person needs to know that and they didn't share it with the other person. So determine a common ground where all of you can sync at once. And lastly, agree on a measure of success. Your project will be checkpointed over time, and you need to identify where you're at. Because if you need more resources, this will be one of the metrics that will come into play in determining what resources or how much resources you will need, and also the success of your project itself. And this brings me to the third habit: coordinate and collaborate. Another story time, turning crisis into confidence. So by this point, I was 6 months into my job, right? So I knew how to manage incidents. I knew where to go to when there was a fire, and I can yell fire. So by this point, I was given the task of essentially updating firmware and patching our infrastructure servers that manage all of the other infrastructure servers. We have thousands and thousands of servers that need to be managed, right? So we have dedicated servers that manage this. In OpenStack, you might call it conductors. But all these servers, they haven't been power cycled in years. They haven't had a firmware update in years and years and years. They could be measured in decades. And also, they're on a very old operating systems. And my company at that time knew this issue, and at that time, so I was given a task to update the OS and apply the new firmware. So I started this project. I have 100 servers that I need to do this to, and these are key infrastructure nodes. So there is a lot of disruption when I do this, and all of the servers that are being managed had been impacted, will be impacted some way or another by this, right? And I started this project. I followed the 4 principles I highlighted earlier, and so I immediately established channels of communication. What I will do, I started identifying the worst case scenarios of when things could break. And also I was proactive in determining these servers that haven't been rebooted. There were servers that had problems with, like the DIMMs are out or the CPU is, on its last thread, right about to die. And what happened was I hit a server, right? It had 4 DIMMs out. So half of the DIMMs were out, half the RAM was down, and the CPU was through some errors. In the logs, you could check that the CPU was right about to give out. And what I did was I knew this was going to happen, so I had the data center team prepped, ready to swap out the DIMMs when I apply the firmware, power off the server. And so I power off the server. I applied the firmware, power off the server, and I get the team to replace the faulty hardware components, and they power it on, and it never comes back up. This was one of those servers that had to be up, and no one touched it in my team for 3 years, and they were like, your problem. So my company is based out of UK, London, and also Dallas. And so I had my team in Dallas that I could fall back on. So we started brainstorming. All right, how are we going to get out of this, right? So for us, we are very security orientated. So our disks are tied, the encryption of the disks are tied to the server serial number. So this meant when a server is down and there's data on the drives, you essentially lost the drives if the serial number of the server is not up and running. If the motherboard is not up and running, it's gone. So that happened, and we started working. Everyone, it was like all hands on deck. We need to get this server back up and running. And so we swap out the system board. We start the painful process of rebuilding another server. And eventually we did bring it back up, but there were important lessons I learned that day. So all right, let me get into that. So scale magnifies complexity. For us, this was a very key infrastructure node. Lots of teams were dependent on it. And, like I said earlier, when you have 1 in a million, right? That's 1 in a million. 10 in 10 million, 50 in 50 million. And when you have jobs, for us, 50 million jobs running daily, there are going to be lots of rebuilds. Lots of infrastructure is going to go through rebuilds. And whenever one of these servers is down, all of that had to be put on pause. And this meant a lot of managers were upset. So they started messaging the managers of my team. And thankfully, because I did document what I was going to do, what the issues were going to be, and I make sure to do a company-wide announcement every time I was doing one of these changes, my managers had my back, right? This is, whenever you're working in in an environment like this, large environments, whenever something goes down, the communication to the leadership, it is quick. But whenever you need something outside of that, it's not as quick, right? So, yeah, and then there's also, my second point is, thorough planning will avoid, it won't fully avoid it, but it will prevent cascading effects. Because everyone deals with incidents differently, right? And incident management, like I said, is a very difficult problem. Some teams will have new engineers on call that don't know how to manage an incident when they're supposed to be your window into that team, right? And whenever I did this planning, I made sure to do it in hours that the UK counterparts could manage. So this was started earlier in the day when things were about to go wrong. And so I started at 8 a.m. roughly, and I had the whole day for me to go through, but I had a very good primer with the engineers that built this whole system. So I didn't really, I didn't really deal with the negative effects of the initial trauma you get when you encounter an issue like this. And lastly, I believe communication is key. Had I not done proper communication, I would have been reprimanded. Changes like this, I know are very big, but you should also consider it for smaller changes. There's nothing wrong in communicating. Sometimes servers do go down, right? Everyone has that server that never came back up. But if you communicate it across properly, and they will understand. You can't have key infrastructure running on half-dead servers, and you can't have them running on OSs that have security vulnerabilities. And this brings me into my fourth habit. Guide future you. How many of you had a problem where you learned something, a year goes by, and completely forgot what you learned? Quick raise of hands. Everyone had that, right? So I will go through a story of how we had a case where I was rolling out a production change. 8,500 servers that I was rolling out a production change to went into maintenance in OpenStack. So if someone rebuilt their server, right, they rebuilt their instance, sorry, the server would never come back to them. So there would be a shortage in compute, and we had almost the whole data center set to maintenance. So all those servers would have gone into maintenance, no compute available for any of the teams to use, and all because of a very small change that I didn't know at the time. So let me start from the beginning. When I work with my team in UK, right, we often do practices where they start a change in the morning, they do the engineering, and at the end of their day, they hand it over to us. And this was a similar case where one of the engineers, started working on a PR to update some of the config for a project work. He handed me over what he had done, and he told me, hey, this is, we need to roll out a production change where we're just restarting some of the agents on the server. So they pulled the latest config from Git, and so we have a very low downtime of our services. And this is done based on availability zones, so pod by pod. And when I got it, I thought I was just rolling out one change, right? I had this PR in front of me. I reviewed it. I knew what to do. I had done this change countless times. We do it multiple times a week. But what I had not known was there was another PR right before that piggybacked onto my change. And that PR had a bug in it. That PR had a very small bug in it that essentially created an issue where the servers, the servers that we're managing, could not communicate back to our conductors, the infrastructure, the nodes that manage the infrastructure. And this meant the conductors were thinking, hey, the server is not communicating. It needs to go into maintenance. And so all of the servers, immediately, less than 30 minutes after I rolled out the change, all of them were in maintenance. And this meant I was panicking. I started going through all the Slack channels, all the help channels that we had to inform all of the teams across all of my company, telling them like, hey, whatever change you're doing today, pause it. Whatever you're doing, pause it. Nothing can go through. OpenStack is in maintenance in a data center. So what I had done was I informed my team in Dallas, and I also called up the team in UK. We couldn't reach the engineers, but I got a hold of the manager. So we started, video chatting. We started going through the bugs, and we found this bug that the manager actually was a part of. I think he was one of the people that actually reviewed the PR, and he didn't catch it, but he had enough context to find out and help me find out where the bug is. And so we started going through the bugs. We started going through the code. We found it, and we rolled out a production change. Within 4.5, 5 hours, we knew where the bug is, but we had to roll out another production change that took roughly another 3 to 4 hours. But we were able to get everything back and running by the end of the day, roughly at 10. Right? This was a very interesting scenario that I never thought I would ever encounter, but I had encountered. Right? So there are a couple things I want to share on where things went good and things didn't. So one of the things that was good was the PR was commented properly. If there weren't comments on why a certain variable was being changed or a certain part of the code was being changed, it would have been very difficult to track down. Especially in a high-stress scenario like this, there were a lot of eyes on us. And secondly, use OneNote, Notion, Confluence, READMEs, whatever you have to do to come up with runbooks for your team for incidents like this. I knew where to go, but if there was a new engineer, they probably wouldn't have if we didn't have these READMEs. It was just a checklist of things to do rather than thinking and processing and who to go to. And lastly, or second to last, review your PR, raise your PRs with details of the actual change. So here's an example of a good PR that I wanted to share. So there's you have the Jira ticket up front. You have a good title. One of the things I see quite often is the branches are named so vaguely. It's that you have to track down what they did, and you have to almost be like a detective in finding some of these branches. Also, the PR description should identify what is being changed, what the exact changes are, a summary, and then also the test plan. And also name your commits. I will show you an example of a bad PR where it's just updates, 1,000 file changes, right? And also no description and it's a firmware fix. It's an Ansible fix for a firmware bug, but what exactly is it? If it's 1,000 files with humans now, attention span less than a goldfish, who's going to go through all of that? And that also brings me to my last point. Review the PRs properly. When you get a PR like that, reject it. Don't be afraid to say no. At the end of the day, this is you putting your word and standing behind another engineer that is pushing out a change. So whatever you're approving, make sure you're going through it and reading it properly. And so that brings me to my fifth habit. Embrace adaptability. So I believe engineers should look for opportunities to be lazy. What I mean here isn't to cut corners. It's to essentially automate. An engineer should find ways to automate things if they could. Script it, document it, whatever you can do to avoid reinventing the wheel, such that you're productively lazy rather than just being lazy. If you do, we have scenarios where we find a bug, right, that an engineer can fix, but if there are 10 of those, an engineer can't fix it timely. And if there are 100 of those, we can't even fix it right away, right? So in key situations like that, being productively lazy is very important. And also, use AI tools or Google before planning. Whenever you get a project, I know we all want to just jump in it, start coding, right? But take a minute or two to actually plan. Someone might have already encountered this bug. The chances of someone seeing the exact same thing you saw is very high. So don't be afraid to use Google. I know there's some slack of using AI tools, but I think it's good to use AI tools for planning. If you're like giving it a CSV file and asking it to parse it, that is a very bad example of using AI. But if you're trying to identify bottlenecks, or even we used to have a concept of a rubber duck, right? Where you're just explaining your ideas to a duck to make sure it sounds cohesive and proper. Do that with AI, right? And also, you can learn by rebuilding, but don't stop there. Go beyond it. Everyone wants to, rebuild Amazon. If you're a programmer, you want to rebuild the UI of Amazon, right? To identify the bugs and what goes on behind it. But also, don't stop there, right? Within your projects, go beyond that horizon. You don't want to spend your time, effectively rebuilding something that is already there. Once you learn a tool, that's good to learn a tool with, like rebuilding. But once you effectively want to test it, you should go beyond whatever they did. Start a different project. Also, you don't need to learn everything in one day. I definitely was accustomed to that concept initially, but when I joined GR, I was like, okay, I have to learn everything. I have to have everything in my bucket of knowledge or my toolbox, such that I can go to this engineer or that engineer, do everything at once. But you don't have to do it. Just lay a good foundation of something, right? If you're learning and if you're new to something, you can fail and people will still be okay with you because you're new. And that was certainly my case. I did not have experience with this particular technology. But I got in and I failed a couple times. But at the end of the day, I knew what the systems were and I learned what I'd done, and the mistakes I've done over time compounded, and those are victories to me now. And that brings on to my sixth habit. Seek first to understand, then be understood. This is another story time where we had a huge project where we were onboarding hundreds and hundreds of some of the latest servers. We hit lots of hiccups. We had lots of teams working on it. We had 4 teams from G Research internally working on this. We had 1 from HPE. We had 2 contractor teams from different companies. But a blue LED fixed the day, or saved the day. So the story is from chaos to clarity thanks to a blue LED. So this project was essentially a couple hundred servers that were split into 2 batches. So the servers themselves had 8 InfiniBand cables. So this is what an InfiniBand cable is. It is essentially a fiber optic cable, and each server has 8 of them. And if you've worked with fiber optic cables, especially like the ones like this, you know how fragile they are and how prone to issues they are, right? If you have dust in your data center, or if you have another data center engineer working on another server nearby, and they pull one of these cables to check if it's properly patched or not, and they pull it, then you have other links going down on another server. And this was certainly the case. The fiber optic on that, like the width of the fiber optic itself was roughly 1/20th of a millimeter on this particular cable. And for us, that meant lots of issues because we did not work with InfiniBand at a larger scale with this particular cable configuration before. And with lots and lots of teams that are stakeholders of this, it was a confusing chaos. We did not know that we were going to hit an issue with cabling. We had lots of cases where we would, the data center engineers would cable something, and we see it, it was cabled wrong, and we did not know how to communicate with that to them. And also, we had our biggest case was, the compute team that I'm a part of. We would work on a server, we would get that server handed off to us, and we would start onboarding it into our ecosystem and start enrolling into OpenStack. But we would find that, hey, one of the links has dropped all of a sudden. So we would hand that off to the data center team, and the data center team would hand that off to the contractor that worked in cabling the InfiniBand optics. And whenever you have this, cadence from one team to another, what happens is you're not going to have the same engineers that work on the same server the next day. You're going to have a different engineer working on the server. You're going to have different team leads working on the servers, right? So we would hand off a server, and that engineer would, incur some delays, and then hand it off to the data center contractor, and that contractor would get it, and then the next day, another data center engineer would also get the server because it wasn't fixed on time. And so that data center engineer would, again, hand it off to the contractor. So the contractor is thinking, okay, we have to have 2 engineers, right? One engineer is going to work on this in the morning, and another engineer is going to validate it at the end of the day. And what happened was they would plug back in the cables of servers that are going through our burn-ins and automation. And this meant the cycle restarted because we would hand it off again because we thought, hey, something is going wrong with networking again. And this was a perpetual cycle. And thankfully, I was in the data center at that time. I saw the chaos. I experienced it firsthand. And I also knew the burden our team felt at that time to hand these servers off to our teams downstream. So I came back to Dallas, right? I was in the data center for 2 weeks. And I was like, okay, I have to think through what solutions we can implement. We can put, key stakeholders like a team individual would own a certain part of the project, or another team individual would own a certain part of the project. But when you have large projects like this, engineers need a break, right? This was hundreds and hundreds of servers. It took hours, almost days to enroll this. And what I ended up finding out was, hey, there is a small blue LED light on these servers, right? That blue LED light, it's called a unique identifier light, all right? My team had already known this light exists, but then we weren't using this light. We saw this light and we were like, all right, it's just a light. But what we found out for this project was, hey, if we turn these lights on and we tell the data center team to, hey, you need to fix this server, but if the light wasn't on, they're not going to touch the server. They should never touch the server if the light was not on, right? And we did that, and we saw a huge improvement in the second batch where we essentially enrolled the servers within a week compared to 2 weeks, 3 weeks for the initial batch. Keep in mind, these were new servers. These were servers that we worked with HPE. So there were lots of other bugs, but this saved us the human coordination issue that we were dealing with initially. And so the things I learned within this project was, large projects can be easily overcomplicated, especially when you have teams from one company, from our company, to another vendor, to another 2 contractor companies. It's going to be overcomplicated, and sometimes you really need to appreciate the simple tools. For us, it was a blue LED light. A blue LED light. It's not, I don't know how much it costs, but it was definitely worth its weight. And also, be curious whenever you go to a data center or whenever you're working with networking teams or Kubernetes teams, especially if you're on compute, right? Try to identify what their challenges are, because those challenges might be a task for you one day, right? For us, updating our automation to just turn on that LED light whenever things failed was very simple. But then for the data center team and for the vendors, that saved them hundreds of hours, many meetings, and also the sanity that you would get from having a good, productive project. And this brings me to my final habit: sharpen the saw. As you learn, your tool, your domain, right? You can go 2 ways. You can become an expert in your domain, or you can understand or learn tools that are downstream and upstream from you. That might mean networking, or that might mean Kubernetes. But you should always try to learn, because whenever you take courses like, the AWS certification or CCNA or CKA, you're learning a new technology, and within your teams, it is very difficult to find engineers that know a breadth of technology or very in-depth. It's often some engineers just get thrown into projects like this without fully understanding the technology. I certainly was. Had I taken some courses, I think I would have been on the better end. But initially, I did not. And I think you should always sharpen the saw in identifying what technologies are out there, and taking courses are some of the best way. And you might find out your company is already offering to pay for some of these certifications. So definitely take up on that opportunity. This might also mean a new role for you in the future. And also, don't be afraid to ask questions. All great projects began with a question somewhere. And, practice good Git and coding hygiene as well. Whenever you're raising PRs in that situation, we had a good PR that was raised, but had it not been for that situation, it would have been a huge issue for me, dealing with that incident. And also keep your customers and teams always updated. It's the turmoil of a project occurs when there is no updates. That is a statement I had to learn the hard way initially from my first experience, where my project kept getting pushed farther and farther and farther back, and more teams started adding things to my bucket list. And lastly, celebrate the small wins. For me, this is a small win. I never gave a talk at a conference, and so thank you for bearing with me. And any questions?
I have a question.
All right.
If you want, I can have it recorded. For the examples for the pull requests, out of curiosity, what repo is that?
That is a private repo I just made for an example.
Oh, okay.
I originally had a repo that I was going to cite with the example of the PR itself that was there that day, but then I shared this with my team, and we learned that, hey, it's probably not a good idea to expose internal usernames and pull requests, so that was kept out. Yep. The back.
What like AWS offers HPC, right? So have you guys explored, going from on-prem data centers to using them? And what challenges are you facing with that migration, if you guys have explored it?
Yep. That's a great question. So G Research, we are a financial research firm, right? For us, speed and security are of utmost importance. We do have an internal AWS team that is used for, compute, but whenever it comes to scenarios where you need compute, but need to have a direct contact with the creator, in our case, it's NVIDIA and HPE, AWS has lots of delays with that. And also the cost is very high for HPC projects with AWS when compared to having your own data center and maximizing the cost savings there. Also, big cloud providers are useful, but their way of architecture is in cost savings, right? So they optimize for fitting the most amount of users on a server, or most amount of compute utilization that you can get from having a server, right? So their technology is focused on splitting up a server into as many users as possible, versus us, we want to get as efficient as possible, and that requires us to get rid of those medium layers. Yeah. Any questions? Oh, we know Sergio. He's from my company.
Give him a chance to give him
Oh,
from your company. Okay.
Yeah, he's from my company.
Okay. No, I think it's a very good presentation. And my understanding, being in the IT industry, is that when you're doing these kind of transitions, very, very critical transitions, typically you said one of the critical nodes, your control plane, was that some kind of old technology. So my understanding is that you move that out to a working server, and then you fix it, right? And so that somehow looks like that kind of that planning or that thought was not possible, or I guess.
So we That's a great point you made. So why not have a system where you have another working node where this can fall back on, right? So we did have this did run in a configuration of a cluster, but the thing was there would be a disruption of the services when we remove that and fall back to another node. And also that server itself was one of the primary servers, actually was the primary server for a whole data hall itself of thousands and thousands of other servers. And in this case, us having a newer version of OpenStack and some of the services, some of the versions of the services that we're running would definitely help. And we actually made the change to do that. If anyone worked with RabbitMQ, they know the problems with Rabbit, right? So that was one of the biggest problems with us. And we later upgraded to quorum queues and high availability queues, which did fix this problem. But at that time, that was not a problem. That was not a solution we already implemented. But hitting incidents like this, you realize the importance of that, and we did have to learn it the hard way. But we did make that change.
Thank you. So related to that question, as you were telling that story about that node you had to bring down, in HPC, because of the volume, right, is it even possible to use like a F5 load balancer or anything like that?
So this was running in a cluster, but it was just older. It was just a config that needed to get updated. It was a schema that was not up to date, and the configuration that we had and the type of services that we were running to manage our infrastructure was just old in this scenario. And we did later update to a more modern version that did have a more robust, handling for situations like this. Now we can just pull one out, and the infrastructure would still be fine. But in that day, at that time, the whole reason why that server went down was because no one wanted to touch it. That server was already, half dead. It had half of its DIMMs out. One of the CPUs was throwing out errors in the logs, and no one touched it. But when I touched it, it just went down. It gave out.
Nobody has a question. I can ask one more. Kind of curious. I heard about OpenStack for many years, and I'm also hearing Kubernetes. Kubernetes already been deployed in many places. And so, are you guys seeing any distinction staying on to OpenStack, and I guess thinking of Kubernetes more? Just want to get your thoughts on that.
Sure. We run OpenStack to manage all of our infrastructure because we have hypervisors, right? We also have bare metal nodes. We use Ironic within OpenStack to deploy it. And then on top of that, depending on the team, you have database teams that don't want to use Kubernetes. They want to do something else, right? And we give that flexibility. But then we also have Kubernetes as our downstream team, and they are actually our biggest customer. And they do use Kubernetes on bare metal. But we use OpenStack for a wider, team approach for other teams.
That is for the HPC production workload?
Yes. Yeah.
Not the administrative workload.
No, not the administrative. Yep.
Production workloads are running on OpenStack.
Yep.
Is there a split OpenStack versus HPC?
So OpenStack itself is a cloud platform, right? HPC is the use of the technology that you're running on top of it. So one of the technologies is InfiniBand, right? InfiniBand, especially with what NVIDIA is releasing recently, they look at some of their newer servers, GB200s, NVLs, right? Those would be considered HPC today. Maybe in another 10 years, probably not. But today, those servers are latest and greatest, and for us, we use that, and we work with our vendors, we work with NVIDIA, HP, whoever, and we onboard that into OpenStack. We have our own open source contributor to OpenStack. If anyone knows Jay Faulkner, he works with G Research, and he's our window into the open source world. But OpenStack itself is a platform, but HPC is the type of hardware and technology you use. Yep.
So it sounds like you're working across a lot of different skill sets and groups, from software engineers, network engineers, data center architects, and everything in between. A lot of times those skill sets and the terminology do not overlap. What have you found has made that more seamless, because a lot of times one term to one group means very different things to another group, and ironing those things out have always been kind of a nuance for me.
That is a great question. So, for example, we have OpenStack, right? Within OpenStack, you have a maintenance flag. If the maintenance flag is true, that doesn't fully mean the node or the server has been drained. You could still have stuff running on it. But if you say that to a data center guy, hey, this node is in maintenance, they can start pulling things out. You don't want that, right? So we try to limit and make sure the jargon we're using with the appropriate teams is correct. But that is a very real, and it's still a problem for us, right? We do also have automation. Automation like reduces that. If you, let's say like you have a dashboard for a data center guy, right? And then you have a dashboard for us, a compute team, and then a Kubernetes dashboard, right? That dashboard could be different for each team. It doesn't have to be the same. But whenever you're having these direct conversations, you just have to understand the space. For us, we go to the data center, right? And the data center folks, the management comes to our offices in Dallas. But you just have to spend time and get that experience. Yeah.
For me, I think I'm trying to over communicating. I take nothing for granted. Every term I'm using, I'm gonna probably find elsewhere in the sentence.
Yeah. We had quite a few scenarios where this was like a long time ago, where we would say that, hey, a server is in maintenance, and the data center team would start working on it, and they already finished their work. They come back to us the next day. They're, oh, that work is done, and we're like, what do you mean that work is done? But those scenarios, you do have to over communicate. You have to have systems in place. That's also another thing, right? If you have a structure of how you're communicating, if you are doing very like day-to-day sort of communication with these teams, you need to have a structure, and also you need to have a common like communication jargon. If one team comes up with a communication jargon and the other team doesn't know that, right? There are going to be issues that will rise. It's just a matter of time. Yeah. Any more questions? All right. Question? All right, going once, twice, sold. Thank you very much.